Sometimes in IT, you get a mystery dropped into your lap, no context and no clues, just a ticking clock and a vague warning that the fate of the world is in your hands if the mystery is not solved. Sound familiar? Well, in today's lab, the mission is to figure out why an app can't connect to a database on port 3306. Hello and welcome to the IT Lab, where I build and test IT solutions. Before we begin, I'd like to remind you that you can try this lab yourself at rajindersidhu.com, and if you like what you see, you should subscribe to receive new posts directly to your email inbox. So, we have two virtual machines in Azure. One is a web server, and the other is a database server. Unfortunately, connectivity is an issue, and VM app can't seem to connect to VMDB. Now, it's tempting to start trawling through the Azure portal to figure out the setup between the two machines, but I want to show you a better way. The most likely cause of connectivity issues are NSGs. Network security groups are one of those things that seem simple on paper, just a bunch of rules that allow or deny traffic. The smart way to troubleshoot NSGs and other connectivity issues is to use Network Watcher. It's got a bunch of diagnostic tools that let you investigate network issues without having to SSH into machines. The first tool in the Network Watcher toolbox is IP Flow Verify. It's used to simulate traffic from one VM to another and tells me whether it would be allowed or denied based on the current NSG rules. So I tested TCP traffic from VM app to VMDB on port 3306, which is MySQL. Connections are made using a random local port, so I used 54321 as the source port. The test shows that VM app is trying to send traffic, but something in its NSG is saying no. I dig into the details and find a rule called deny VNet outbound. That's explicitly denying outbound traffic. Then I test the reverse, VMDB to VM app on port 80, which is Apache. Same setup, same source port. Although the problem to solve is connectivity between VM app to VMDB, it's a good idea to check connectivity on the way back because TCP connections require a two-way handshake. If VMDB can't route back to VM app, the connection will fail. This connection is also denied. This time, it's the default rule in the VMDB's NSG. This doesn't make sense because the default rule for VNet to VNet connectivity is present before the default deny rule, so it may be a problem with the VNet. Next up, the NSG diagnostics tool. This tool gives you a bit more context. It doesn't just say denied, it tells me why it was denied and where the rule is coming from. From VM app to VMDB, I can see the deny rule is applied directly to the NIC. That's important. It means the rule isn't inherited from the subnet. It's been attached specifically to that VM's network interface. From VMDB to VM app, I set the target VM and the source and destination IPs. This time, the deny rule is coming from the subnet level NSG. So it's not just VMDB, it's every VM in that subnet that's being restricted. So there's two layers of restriction, one at the NIC level, one at the subnet level. Without knowing the configuration of the two VMs, these two tools have given me key information to troubleshoot the connectivity issue. I move on to the next hop tool. It tells me where traffic is supposed to go next, based on the routing configuration. It's a good way to catch things like misconfigured user-defined routes or broken VNet pairing. Both VMs show virtual network pairing as the next hop. Although this may not seem like much, it tells me that the VMs are in separate VNets and that pairing is in place. So I dig into the pairing settings and sure enough, it's only configured one way. VNet app can route to VNet DB, but VNet DB can't route to VNet app. This is an asymmetric pairing setup, meaning traffic knows where to go in one direction, but not the other. The next tool allows me to see the effective security rules on both VMs. VM app has rules applied directly to the NIC. This means it's got its own private rule set separate from the subnet. VMDB, on the other hand, inherits its rules from the subnet, so any changes to the subnet NSG affect every VM in that subnet. This distinction matters, especially when you're trying to figure out why one VM behaves differently from another. It's not always obvious unless you look here. Armed with the troubleshooting information from these tools, I can go ahead and rectify the peering and NSG configurations. Before I do that, there's one tool left to show you: Connection Troubleshoot. This tool is like the summary page of the whole investigation. You give it a source, a destination, a protocol, and a port, and it tells you whether the connection would succeed, and if not, why. I test VM app to VMDB on port 3306 and VMDB to VM app on port 80 with the same random source port and same protocol as before. As expected, both tests come back denied, but now I've got a full diagnostic report that lays out the NSG rules, the peering configuration, and the routing path. It's everything I need to try and resolve the problem. I removed this rule that's blocking outbound traffic on the VM app NIC. I also removed this rule that's blocking inbound traffic on the VMDB subnet. Lastly, I deal with the peering issue by allowing connectivity from VNetDB to VNet app in the peering settings. Now, when I run the connection troubleshoot test, the tool confirms connectivity. Using the tools in the Network Watcher toolkit, we were able to identify connectivity issues quickly and resolve these issues logically. So once we knew where to look, the fix was straightforward. Adjust the NSG rules, fix the pairing, and the traffic began to flow. And that's the whole process, from a mystery issue of two VMs refusing to talk to each other to a clear resolution. No guesswork, no assumptions, just methodical troubleshooting, one tool at a time. Before I go, let me remind you to subscribe on YouTube for more videos like this. Oh, and go to rajindrasidhu.com right now and try this lab yourself. I'll see you in the next lab.